All right, so this is going to be a short video talking about the answers to the midterm. People did pretty well by and large. I put the grades on the tests themselves. If you have any questions, just let me know. So let's go over the answers, okay? Question one. Most of you got almost all these. Opportunity cost, everybody got that. That's what you give up in order to get something else. Price elasticity of demand is the percentage change in quantity in response to a percentage change in price. So it was important for the proper answer, if not all the points, to get the idea it's a percentage change, not a unit change. We had this this little discussion of how if it's a slope and you're talking about units, depending on currency and so forth, you can get a very different slope. If everything is scaled in elasticity, percentage change, then that's units free. So that's a substantial advantage. Normal good is a good for which the income effect is positive. And the income effect is a change in income or change in purchasing power holding a relative price is constant, right? So it's the idea that that in a budget constraint kind of world, the budget constraint is moving in a parallel kind of way, right? Reflecting the fact that relative prices haven't changed. But real income is the purchasing opportunities that you have for the composite good, and whatever good is down here. Income goes down, prices stay relatively constant. Your purchasing power, your ability to buy combinations has gone down. So normal good is when that income effect, holding relative prices constant, you're just changing real income, is producing a change in quantity, right? And usually you'd expect, in the case of a normal good, the income effect is positive. In the case of an inferior good, the income effect is negative. So a normal good is the instance where a change in real income is producing the same sign change in terms of quantity demanded. Producer surplus, most of you got that. You know, it's this area under above the supply curve, below the price that gets established. The idea is that some producers, low-cost producers, would be willing to supply a certain amount to the market, even if the price was much lower than it turned out to be. And then as the quantity increases, fewer and fewer, well, as you bring additional producers into the market, their costs aren't as low, so they're going to require a higher price to be willing to offer things on the market. And that accumulation of willingness to supply to the market below this equilibrium price is the producer surplus. It's represented by this area here. Okay, number two, most of you got this. It was on the review problems. The idea is that you know that the price elasticity of the demand for pork is 0. The more pork she has, the more she's willing to give up. That just implies indifference curves are convex, the kind of normal assumption. And from those two, you can determine that pork for Gretchen is a inferior good. And to see that, we can start with Becky's demand curve. Demand curve has quantity down here and price up here. We know it's perfectly inelastic. So that means as the price changes from, let's say, P1 to P2, the quantity demanded by Becky isn't going to change at all. So take that knowledge and move to Becky's preferences and budget constraints. If the question asked for whether something's an inferior good or normal good, you've got to be dealing with this kind of preference space where quantity of pork is still on the x-axis, but instead of price over here, now it's the composite good. And let's see what happens when you go from P1 to P2. We know from the demand curve, the quantity doesn't change. So let's start with this lower price, which is going to give us a budget constraint reflecting that price. The tangency, we know the indifference curve is going to be convex by assumption in the problem. There's going to be some equilibrium point A. And we know that that equilibrium point is going to be a tangency corresponding to a certain amount of pork, QA, which is exactly the same as QA over here. So now we want to go from P1 to P2. Price has gone up. So the budget constraint is rotated back. And what we know is that this indifference curve that's tangent to the lower budget constraint has to be tangent at this point. And it has to be tangent at this point because this point corresponds to the same QA that this tangency did, right? As we go from P1 to P2, QA isn't changing. So as we go from this relative price to this relative price, QA isn't changing either. So we have some tangency. If this is point C, we want to know what the substitution effect and income effect are in going from A to C. We have to do what we did in class, which is to first find the substitution effect. Substitution effect is the change in quantity demanded owing to a change in relative prices holding utility constant. So we want to start at this higher level of utility, keep that constant, which is to say we want to be on the original indifference curve. But now we want to reflect these relative prices instead of these relative prices. So it's going to be something like this. We know that if the price of pork has become relatively more expensive, that Becky will substitute away from it. And so we'll go to a point like B, which corresponds to a quantity of pork demanded at QB. So that's the substitution effect. But by construction, we know that the income effect has to take us back to A because we know we're going to, with QA, because we know we're going to end up with QA because demand is perfectly inelastic. So C is this point, B to C is the income effect. We're reducing real income because the budget constraint is rotating inward, but at the same time, we're increasing quantity demanded from QB to QA. So if the income is going down and the quantity demanded is going up, that's the definition of an inferior good. So you know from construction of this problem, and the big clue was that price demand is perfectly inelastic, that pork for Becky has to be an inferior good. Okay, on to number 3. Okay, let's keep going here. Number 3, I think almost all of you got these 3 parts correctly. We're starting out in some equilibrium, looking at quantity of enrollment per year, number of students per year, price per year in tuition. There's going to be some sort of supply and demand curve determining with this kind of quality constant world in college, what the equilibrium quantity is going to be and what the equilibrium price is going to be. So you're asked to show what happens to tuition and enrollment in a number of scenarios, right? One is a clamp down in diploma mill colleges, shuts them down. So what that's going to do is increase the supply curve back. There are fewer institutions willing to supply a four-year college education at any given price. Supply curve shifts back here. What that means is that enrollment will fall and tuition will increase. Second part, it's learned that the payoff to a four-year degree is higher than what people thought. What that should do is increase the willingness of potential students to enroll, because it's been shown that enrollment in a four-year degree is worth more than what they thought before. Demand is going to shift out. Number of students enrolled is going to increase, but tuition is going to increase as well. The third part is same as the first. Now we've got a situation where costs go up because the property tax exemption has been eliminated. What that means is that it's just like a tax. Well, it is a tax. Supply curve is going to shift back, enrollment is going to decline, and tuition is going to increase. So that was pretty straightforward, and I think everybody got it. Number 4, we've seen versions of this. There's a version of this in the book too. The idea is that we're going to try to reduce carbon consumption by imposing a tax on carbon. But the twist here is that instead of just imposing the tax and using the revenue for something else, we're going to rebate the tax revenues back to consumers in the form of a lump sum dividend. There was actually a proposal for this a number of years ago. So it's the kind of standard analysis up to a point. We know that when we impose a tax on carbon, the price of carbon is going to go up. So whatever the relative prices were before the tax are now going to change. The budget constraint is going to be cheaper because the price of carbon has gone up because of the tax. And a consumer with these preferences is going to go from consuming, well, were there no rebate, the consumer would go from consuming Q sub A to Q sub C, right? So that's kind of the standard, let's impose a tax and let's use the money for something else. The tax makes carbon more expensive, so people are going to substitute away from it. And a higher price is going to reduce real income. So we're going to get these reinforcing income substitution effects. But if we add in this element of this rebate, then we're going to have the regular substitution effect. Relative price of carbon is increased because of the tax. So if the tax is going to give us relative prices reflected by this steeper slope, we want to do the normal kind of substitution effect, which is going to roll around the indifference curve from point A to point B. In other words, Q sub A to Q sub B. So because the price is higher, we're going to consume less carbon. If we didn't get the money back, we would be taken down to point C because the real income had fallen. Now what we're doing on average is not causing real income to fall because we're rebating tax revenues back to consumers. Now, on average, what that's going to do is enable people to go back up to their near their original indifference curve. There's going to be a lot of heterogeneity here. Some people are going to get more of a rebate than what they were paying in the carbon tax, some less. But the principle is that regardless of how much this real income shifts you back, you still face a steeper price for carbon, and you still have the substitution effect. So we don't know where QB is, but we know QB is going to be to the left of QA. In other words, there's going to be less carbon consumed. And there'll be some winners or losers in terms of to what extent the dividend, the per capita dividend, gives you back more money than you were paying in the tax or less. But the basic principle is it's not taking out of one pocket and putting it in the other, producing no change. It's causing a substitution away from carbon toward the composite good because relative prices have changed. All right, final question. We have a case of a tax, a per unit tax of $10. We want to know whether the burden of that tax is going to change with changes in the short run versus long run, which is going to be changes in the elasticities of supply and demand. And what are the consequences of going from the short run to the long run for tax incidence? Short run case, we have the black supply curve and the black demand curve. If we impose a per unit tax on the firms, let's say, supply shifts up by the amount of the tax. And our equilibrium quantity, Q star, P star, falls back to Q1 because the supply curve is shifted up. Prices increase to P1. Now the burden is going to be how much the price increased relative to how much the supply curve shifted. In other words, the amount of the tax. And if you look at the graph, the price increase is going to go from P star, which is the original equilibrium price, up to P1, which is the new intersection point. So that's the numerator, that's the price increase, but then we want to relate it to the amount of the tax. And graphically, the amount of the tax is just the vertical distance between the old supply curve and the new supply curve. We shifted the supply curve up by the amount of the tax. So where that new quantity, Q1, intersects the original supply curve, that's going to give us, this distance is going to give us the amount of the tax. So it's going to be this distance from P1 to P2. So that's the denominator graphically, P1 minus P2. And in this case, it looks like maybe half of the burden falls on consumers, with this distance, the amount of price increase being about half this full distance, which is the amount of the tax. So that's kind of a standard short run analysis of tax incentives. Now what happens when we go to the longer run? And the key insight here is that demand may become more elastic in the long run as consumers find substitutes. But supply is almost certainly going to become more elastic. And there are reasons for most industries that it becomes perfectly elastic. And the idea is that for producing whatever good we're talking about, good or service, there's some optimum low-cost point of production. In the short run, people are stuck with the equipment that they have, and they might not be able to gear up to produce whatever this is at that lowest possible price of production. In the long run, by definition, their decision horizon has lengthened. They're able to make whatever investments they need in order to produce this thing at the lowest possible price. So if you're thinking about supply, they're going to want that the price that they are willing to supply at has to be that cost plus a normal profit on that investment that they've made. but you're going to have an infinite number in a competitive market of these potential suppliers willing to come in and offer at that same price. So I drew a little bit of slope here. Actually, let's make it more extreme and have the slope reflect a perfectly elastic supply. That makes it easier. Now, if we impose this tax, we're going to get a shift in the supply curve up by the amount of the tax. And a supply curve is perfectly elastic. It doesn't make any difference what the demand curve is. It can be straight up, it can be somewhat, it can be slanted in the way the original demand curve was. It can be more elastic, but the elasticity is just going to determine how much quantity falls. The incidence, you're always going to get the consumer, the producers able to pass the full tax on to consumers because the supply curve is perfectly elastic. As long as it's perfectly flat, whatever tax is going to be levied on the producers is going to be reflected in a price increase of exactly that amount. So the answer was that in the long run, you'd expect the burden of the tax to fall more and more on consumers, and in the extreme with a perfectly elastic supply curve, the burden is going to be 100% on consumers. So the lesson here, the policy lesson was, if you think you can get at firms by taxing them, in the long run, provided that decisions can be made to produce a fairly flat supply curve, in the long run, whatever tax you impose on suppliers is going to be passed on to the consumers in the form of higher prices. And if supply is perfectly elastic, that's going to be 100% of a shift onto the consumers. Okay, so if you have any questions about your migrating, please just set up an appointment with me.